Greetings to the whole world. It is time to get the ball rolling with exercise 5.33. Okay, and it's not. Oh, it seems like it is one of those challenging exercises, but we'll see. Okay, so since it has two asterisks, it is considered as a problem which is a bit more challenging compared to others. Okay, so a positive integer is called a perfect number if it is equal to the sum of all of its positive divisors, excluding itself. For example, 6 is the first perfect number because 6 plus 2 plus 1, because 6 is equal to 3 plus 2 plus 1. Okay, the next is 28, okay, which is equals to 14 plus 7 plus 4 plus 2, okay, plus 1. Okay, there are 4 perfect numbers less than 10,000. Write a program to find all these 4 numbers. Okay. Okay, let's do so without any waste of time. Okay, so right here I'll simply, on this variable, I'll simply hold the sum of divisors. Okay, what I will then do, I'll have a loop there will have a number to check starting from 1 up to 10,000, of course. In fact, you know what, let's do it this way: 1 2 3 4. It's okay. Number to check, is it greater than or equals to 1? If that is the case, 6, we don't have to go all the way to 1, because we know our first perfect number is 6. Okay, so let's go number to check, minus. Okay, now that I've got that, let me initialize my sum of divisors. I'll initialize it to 0. Okay, I'll then have an inner loop which will try numbers starting from 1. Okay, it will basically contain my divisors. Okay, starting from 1. You know what, let me start it from a number to check. Starting from a number to check. Okay, divisor. While divisor is greater than or equals to 1. Okay, divisor minus, not divisors, it's divisor. Okay, tell me something about this loop of mine. Okay, question 1. Okay, I'm asking you guys to comment on my outer loop. Tell me, what is it you think would be better if decide to do. Okay, that's my first question. And secondly, here's the question: you don't want to think of switching from a for loop to a different kind of a loop all the time. There are other things that you can comment based on. it does not necessarily have to be changing from one loop to another. Okay, so let's continue. Where were we? Okay, we are actually now have to check if our number to check is divisible by divisor. If our number to check is divisible by divisor with a small letter, of course. If that is the case, number to check with a small letter there. Okay, if that is the case, we know that we have to add that to our sum of divisors. What divisor? And once we're done doing that, we're gonna have to now check if our sum of divisors is equal to number to check. If that is the case, then we know that we have our perfect number. Okay, system.out.print. Give me a break. Okay, system.out with an S there, of course. It's system.out.print. You know what? There's absolute number to check. \t, because you know we only have 4 of them, we're being told. Okay, now that we've got this, let's hit the run button and see what we get. Let me scroll up and see if I didn't mess up. I hope I did not. One, two, three. Then why not? Okay, number to check, is it greater than or equals to 6? If that is the case, we do that. So now divisor starts from number to check, while divisor is greater than or equals to 1, then we decrement divisor. So if number to check mode divisor is equals to 0, then we add that. We add that to our sum of divisors. Okay, once we're done with that, we want to check if our sum of divisors is equals to number to check. That seems okay. Why is it not displaying? Oh, it's because here's my mistake. I started from a wrong number. You see right here, our divisor shouldn't start from number to check. It's supposed to start from it's not supposed to start from number to check. It's supposed to start from a number less than 8. For instance, a number like that. Okay, but we can make our program work even more efficient by starting from halfway through, right? Okay, and you will see this still works. Again, we can make it even more efficient by starting from the square roots math.sqrt. We can start from the square roots of a number to check. Okay, again, you'll get the same results. Of course, we need to typecast that to an integer. Oops. Did I mess up in some way? Seems like I did, but I mean, yeah, you guys do get the point here. You know what? Let's use that, because I don't want to keep explaining. This does the job, doesn't it? Okay. See you guys on the next tutorial. Now that we have a working solution, I'm gone. But make sure, folks, you tell me is question 3. Question 3. Please give me a comment on this program, because there are certain things that I could have improved, I could have done in order to improve our program, but I did not do them on purpose. And if you think I'm messing with you, I'll give you an example. You see, for instance, we could have it seems like now I'm about to give you an answer that I wanted you guys to tell me about in the first place. So there will be no point of having this question 3 as a question if I tell you this. You know what, let's just forget about it and let you do the job. Okay, so for now I'm gone. Cheers.